We will illustrate the rest of this lecture with this example drawn from the AI literature. It is called the Wumpus World, invented by George Job in 1975. So the Wumpus World is actually a cave of 4 by 4 rooms. So we have 16 rooms that are interconnected, and we have an agent that evolves in this environment. And the idea is that this room actually have some danger, and this danger can be either a beast called the Wumpus that would eat anybody who gets into the room. It is also has what we call a pit, and the pit is actually a bottomless, and whoever falls in the pit would be stuck there forever. There are examples of pits and bumpers. So we have an agent that starts a room 1 1, and the mission of the agent is to navigate in this environment or the cave without being eaten or without falling into pit. There is some reward. It is possible for the agent to discover some gold and get it and get out of the cave. So there are some other components which is that help the agent navigate in the cave. If the agent is in a room that actually is close to a pit's room or bumpus room, this one will be smelly. So it would have some stench. If the agent moves to a room in which there is some breeze, it means that there is some next room that has some pits. So the pit emits some breeze. So there are some percepts that can help the agent navigate without being eaten or fall into the pit. So let's start formalizing the problem of the one Wumpus world. So we have a 4 by 4 grid of rooms in the cave. Squares are called adjacent if they are on the same column or the same line. So anything that's on the diagonal are not. So for example, these two are adjacent and these two are adjacent. All right, but these two are not. So squares that are adjacent to a bumpus have some stench smell. So we have a stench here and here. Because the cells are close to bumpus, such as these two, these three rooms have some breeze. This is what the pit emits. If and only if there is a gold in the room, also shooting the bumpus with the only available arrow will kill the bumpus, in which case it will lead to very big scream that can be heard anywhere. In the cave, also grabbing picks the gold in the same room and releasing drops the gold in the same room. All right, so this is the Wumpus world. So let's now define the Wumpus word in terms of peace environment criteria. So remember, peace stands for performance, environment, actions, and sensors. For the performance measure, we are going to add 1000 points if the agents get the gold. We are going to subtract 1000 points if it is eaten or fall in a pit. We are going to subtract 1 point whenever the agent makes an action and minus 10 if the agent chooses the arrow. The game ends either when the agent dies or come out with the gold. The environment is a 4 by 4 grid of rooms. The agent starts in the bottom left room, that's the room 1-1 facing to the right. Location of the gold and the Wumpus are chosen randomly with a uniform distribution from all squares except the first start square 1-1. Each square other than the start can be a pit with some probability, which is actually a probability of zero point 0.2. So the actuators are left turn, right turn, forward, grab, release, and shoot. And the sensor would be stench if there is Wumpus in one of the adjacent rooms, a breeze if there is a pit, a glitter if there is a gold in the room, a bump if the agent is facing a wall and trying to go forward, and a scream is if the Wumpus is killed. This can be represented as a 5-element list in which we have an indicator for each of these sensors. So for example, stench, breeze, none, none, none express the fact that there is in the adjacent room a Wumpus and a pit. So we have to figure out which room have actually these two elements. The Wumpus word properties are as follows. It is partially observable because the agent can only perceive it as a closed environment. Like the adjacent rooms, it's static. We know exactly the actions and the outcomes. It's a single agent. It's deterministic. Finally, it's sequential. Now we will introduce some informal language using symbols in the grid. And do some logical reasoning about how the agent should evolve in the cave. So initially, the agent is in, these are the first steps, the agent is in the first room. And we know that by default, this room is safe for the agent. So the room we are going to add the symbol OK to say that the room is OK to be in. So the room is safe. We are going to use the symbol A for agent, B for breeze, G for glitter of gold, OK if the square or the room is safe, P for pit, S for stench, V for visited, and W for Wumpus. Alright, so initially this room is safe means that there is nothing in there. But also by looking into these rooms, it says that there is no breeze or no Wumpus around. It says that there is no breeze or no Wumpus around. So he could either move to the room 1 2 or to the room 2 1. So suppose we pick up to go to the room 2 1. Then the agent will move in this room here. This room is visited. This room is visited. But this room actually has a breeze, which means that there is potentially a pit here or here. So I'm going to add the question mark to the symbol pit to say that is this a pit? Okay. So here the agent will think and not make any hazardous actions. So he need to really be careful. So what would happen is that the agent would need to come back to go back to where it came from and explore maybe the room 1 2 before moving forward through any of these rooms. Given that there is a risk, it falls in a pit. So what I just did is an inference or a complex process in which I figured it out, thinks which room to go, where is the gold, where is the Wumpus, where is the pit, based on different time points, different locations, and all the percepts that the agents has perceived. So this is kind of complexity that we want to be able to embed in the logical agents using this kind or some sort of presentation to navigate into its environment. So in the rest of this lecture, we will study how to build logical agents such as the Wumpus that can represent information and draw conclusions to make the agent progress in its environment.